Okay, on this example, they're telling us the terminal side of an angle is at 8,5. Find the values of the other all six trig functions. All right, how do we do this? First off, let's change this example. I want to make it to be a little harder. So instead of 8,5, let's make it, how about 8 minus? I want to make one of those negative, just so we do a harder version of the problem. So let me get rid of that. So 8 negative 5. So what are they talking about? Well, first off, let's draw. So when they give you this, what are the steps? So when given a point where the angle ends, that's what we're talking about. That's the kind of question we have here. There's a point where the angle ends. What should you do? Step 1. Draw, or how about find the point? Find the point on the axis system and draw a triangle. Whoops, try this again. Draw a right triangle to the point and to the point between origin to the point, from origin to the x-axis. So let's try that. So let's come up here. So there's a coordinate system. We're looking for the point over 8, down 5. So let's just go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So down 5 over 8. There's my dot. So let's draw ourselves a triangle straight to that point from the origin to the x-axis. Oh, whoops! I thought I was in the tool mode. I was not. Let me try again. There we go. So, and then this will be a right angle. So there we go. So you draw your triangle. So this is the point right here, over 8, down 5, the point that I made up. And I draw a right triangle to that point from the origin to the x-axis. Notice I didn't go over here to the y-axis. That's important. You'll get your angles wrong if you go to the y-axis. Let me write that. Not the y-axis. Okay. And now, step 2 is you have to use the definitions for sine, cosine, tangent. Now, sine, we often say it's the y-coordinate on the unit circle, and that is true. But there's another definition. This comes from SOHCAHTOA. You probably know about this one already. Right? Sine is opposite over hypotenuse. Cosine is what? Adjacent over hypotenuse. Tangent is opposite over adjacent. And then the other 3 trig functions are just reciprocals. They're upside down of the first 3. So they are cosecant, which is upside down of sine, secant, which is upside down of cosine, and cotangent, which is upside down of tangent, but I'd rather write it as, well, yeah, no, that's good. Let's just write it as upside down of tangent. That's good. All right, so that's how we find them. So let's go through them. So now we know, yeah, one thing I forgot is to put the angle. Yeah, so let me say, this is step 2. Put theta at the origin. And then this will be, it's a little step. That'll be step 3. So put theta at the origin. So there's theta, which means this is the opposite side from theta, right? This is the opposite. And this is across from the right angle. So this is the hypotenuse here. And therefore this is the adjacent side, meaning it's right next to theta, touching it like your neighbor lives adjacent to you. Okay, so let's go through the angles now. So now what do we have? Sine is opposite over adjacent. No, I'm sorry, opposite over hypotenuse. Let's go get that, opposite over hypotenuse. That's, oh wait, I forgot to put them in here. This is over 8 down 5. Isn't it? Oh, and I am put theta at the origin and find the hypotenuse by a squared plus b squared is c squared. The Pythagorean theorem. I forgot. That's important. So we got to find the Pythagorean theorem. A squared. Let me scoot it over here. That was not the eraser. All right. Still not in a good mode. There we go. A squared plus b squared is c squared. So that's going to be 8 and negative 5. That's my a squared and my b squared. 8 squared plus negative 5 squared is c squared. C is always the hypotenuse. That's the longest one, right? It's the longest side. So the other two add up to equal it squared. So then we get 64 plus 25 is c squared. What is that? 89. I'm kind of running out of room, aren't I? I'm going to erase some of this here. 89 is c squared. Root it. So c is the root of 89. So root of 89 is the hypotenuse. All right, let's do it now. So now we can do sine opposite over hypotenuse. Opposite hypotenuse. Negative 5 over root 89. Now we can't leave roots in the bottom. You probably know that already. So we have to get rid of that. So multiply top and bottom by root 89 and we get minus 5 root 89 over plane 89, right? Because root 89 make a plane 89. So let's put a box around that. That's our first answer. Next one, cosine. Cosine is adjacent over hypotenuse. Adjacent is 8 over hypotenuse root 89. 8 over root 89. Again, can't leave a root in the bottom. Multiply top and bottom by root 89. Get 8 root 89 over plane 89. Here we go. Now for the third one, tangent, is opposite over adjacent. So opposite over adjacent, negative 5 over 8. Don't have to mess around with any roots and denominators. There we go. Now the other three are just upside downs. So the upside down of this, now if I grab it like it is, if I grab this, if I flip this, do you see I'm going to have a root on the bottom? It'd be better to grab this and flip it. So I'll do that. I'm going to flip it. Root 89 on the top, 5 on the bottom. Just put the negative in the front. Doesn't matter if the negative's top or bottom. It's in the front. It's all the same thing. So there we go. Whoops, that was not so good. If I can do this over here in the corner. All right, there's the answer for that. We just flipped it. Same thing for the next one. We don't want to flip this because see that root will go to the bottom and we'd have to mess around with the roots in the bottom. Flip this one, which is what it was before it simplified. These two are the same. We just multiplied top and bottom by root 89. Do the same thing to top and bottom. You don't change it. You just change the way it looks. So these are the same. So we might as well just flip this one. Would be easier. That way we won't have to mess with the roots on the bottom. So this will be root 89 over 8. There we go. And the last one, just flip this guy, and you're going to get minus 8 over 5. And there we go. That's how we get all the answers for that. So we just had to draw that triangle where it was at, over 8, down 5, and then do the Pythagorean theorem to find the hypotenuse, and then use the definition of SOHCAHTOA to find all the trig functions.